Welcome back, College Algebra. This is going to be the second part of the 8-2 lesson. We're talking about hyperbolas here. And remember from the end of the last video, I had this equation up here. And this is the equation of a hyperbola. And our job is to figure out how to graph this hyperbola. We might not actually graph it, but we at least need to get it into a form where we can graph it. We need to get this into standard form. So what we're going to have to do is we're going to have to complete the square in the x variable and also complete the square in the y variable. Now, completing the square is something that you've done before in this course and in other courses. But remember one thing, you can't complete the square if there's a coefficient other than 1 on the squared terms. So what I'm going to have to do, and if you pay very close attention to each step of this, you'll be able to do these just fine. In order to create a perfect square trinomial in x, the first thing I'm going to have to do is factor a 4 out of both of the terms that have x in them. So I'm going to put a 4 here, and I factored it. You see, 4 times x squared is 4x squared. 4 times negative 6x is negative 24x. And then I'm going to leave a space there. And then to create a perfect square trinomial in y, I'm going to have to factor out a negative 9. Okay, so I'm going to write negative 9 y squared and then minus 8y. Oh, whoops, I almost made a big mistake. Negative 9 times negative 8 would give me positive 72y, but I need a negative 72y, so that's going to be a plus. So negative 9 times positive 8y gives me the negative 72y. And the other thing I'm going to do is I'm going to go ahead and subtract that 144 over to the other side, like so. Okay, so step 1, I factored a 4 out of the x terms in order to make the coefficient on x squared be 1. I factored a negative 9 out of both of the y terms in order to make the coefficient on y squared be 1. And then that constant term I subtracted from both sides, which gives me negative 144 on the right side. Right now, I'm actually not quite finished with this step yet. If you remember when we complete the square, what we do is we say the method is you take half of that coefficient. So half of negative 6 is negative 3. Square that. Negative 3, if I square it, becomes positive 9. Negative 3 times negative 3 is 9. And that's what I add right here. I've just created a perfect square trinomial by completing the square. I'll do the same thing here. Half of 8 is 4. If I square 4, I get 16. Like so. Now, I've now created a second perfect square trinomial, this time a trinomial in variable y. I know what you're thinking. Wait a second, you just added something to the left side of the equation. In order to keep the equation balanced, don't you need to add the same thing to the right side? And you're absolutely right. Yeah, I'm still not quite finished with this step. So I did put a plus 9 there. But notice that that 9 is inside of a quantity that's being multiplied by 4. So essentially by putting this plus 9 here, I've increased the value of this side of the equation by 4 times 9, 36. So to balance the equation, I'm going to add 36 over there as well. Okay, on the right side, I added 36 to both sides. Now, I put a plus 16 here, but that plus 16 is inside a quantity that's being multiplied by negative 9. Well, negative 9 times 16 is what, negative 144. So to balance this equation, I'm going to have to, I essentially, by adding this 16 here, I've subtracted 144 from the left side, okay, from this side. So to keep it balanced, I'm going to have to also subtract 144 from that side as well. So I think everything's balanced now. Now what I'm gonna do in the next step is I'm gonna factor each perfect square trinomial. Now, so I've got a 4, and then this perfect square trinomial, of course, it's x minus 3 quantity squared. So that x squared minus 6x plus 9, that quadratic trinomial factored into x minus 3 times x minus 3 for just x minus 3 quantity squared. And then okay, minus 9, and then this perfect square trinomial will factor into x plus 4. And then over there, on the right side, I'm going to have to clean that up just a little bit. Let's see, I've got negative 144, take away another 144, that's negative 288. And I've got to add 36. So negative 288 plus 36, 288 minus 36, I guess, is negative 252, I think. All right, now, this looks a lot better than this. If you remember, though, I need to get this into standard form. So what I'm going to have to do is, and there are no ifs, ands, or buts about it. To be in standard form, there has to be a 1 on the right-hand side of the equation. Okay, so I'm going to divide, I can turn a negative 252 into a 1 by dividing by itself. I'll just divide by negative 252. Negative 252 over negative 252 will equal 1. But if I divide the right side by negative 252, I have to do it to the left side as well. Both terms, okay? I'm going to put this term over negative 252. I'm also going to divide this term by negative 252. Right now, 4 over negative 252, I think, reduces, let's see, 4 times 63, yeah, I think 4 times 63 gives me 252, so I'm going to rewrite that as negative 4 over the negative 252 became negative 1 over 63. And then a negative 9 divided by a negative 252, that'll become a positive. And it'll be, whoa. I have an x there, okay. That should be a y, right? That was the y, okay. No biggie, I fixed it. All right, so that's going to be y plus 4 squared divided by, let's see, what is 252 divided by 9? I think that's 28. And this is almost in standard form. But if I notice that first term is negative and the second term is positive, so I think what I'm going to want to do is just switch them. Remember, addition's commutative. I can rearrange this to put the positive term first. I'll just write y plus 4 squared over 28 minus, because this term's negative, x minus 3 squared over 63 equals 1. Okay, now, the rest of that problem asks you to, it doesn't say graph it, but to answer the questions, you're going to have to graph it. This right here, to graph this is not probably a big deal. I can tell it's going to have a vertical transverse axis, just like the example I did in the first video. The center would be at 3, negative 4, okay, and then I'd go square root 28 up and down from the center, square root 63 left and right from the center. And I know 28 and 63 are not perfect squares, so you just kind of have to estimate that when you're making your graph. 28, the square root of 28 is a little more than 5, so you can go 5, and then units, and then some, same way there.
Cool.
Hey, Tom.
Hey.
You can come here. I love you so much.
Love you too.
So listen, I mean, there are going to be some subtleties that you encounter that are not going to be perfect. Or, you know, I mean, you may have to think about them just a little bit. Maybe, I mean, you email me with questions and such. I mean, I can put something on a video. We can have a video chat if you want about any smaller topics. Thanks for watching. Have a good day.